remaining and everything. And also what the Scrum Master does is that he now divides the features. He says, development team 1, you work on a feature called camera. Development team 2, you work on a feature called, let's say, something like phone calls. Team 3, you work on a feature called messaging. So now I am dividing my features into individual components, and these individual components are now called user stories. We call them as user stories out here. So features, multiple features which contains user stories out here. I'm dividing those user stories out here and giving, let's say, to individual clients out here, individual development teams out here, and these development teams are parallelly working with each other. One development team is working with this one, and one more thing that I want to introduce right now is that now I'm telling, at the end of the day, if you are writing one piece of code, test it using the tester. I don't want the tester to come after 1 month right now. I want the tester to come at the end of the day before my stand-up call. The tester has to test it. The tester also needs to tell what have I tested, what are the issues, so that we can address it tomorrow. And are the issues addressed tomorrow? So this is called testing oriented development, meaning tester is giving you regular feedback, and this feedback is helping you develop better things, so that your testing is not separate right now. Your testing is now an integral part of your development. So now I'm telling, okay, fine, testing is an integral part of the development. Again, now they are asking, okay, how much time we have to develop this out. Now I'm telling, the development will happen not in times of months, but the development testing will happen in a quantitative measure called sprint. We call a sprint cycle. Each and every sprint, depending upon your organization or depending upon your project, can go between 2 to 4 weeks, 14 to 30 days. That's what I'm telling. And before beginning each and every sprint, meaning today is the start of one particular sprint called sprint 1. Before starting the sprint, we have something called as a sprint planning call, wherein we understand a couple of things like how many holidays are there in the sprint, how many people are actually working in this sprint, because some people in my development team can be on a long leave. They can be on a long leave, so I cannot accommodate them. So how many holidays are there? How many working hours are there? Depending upon which, I will have a word with my client telling that, you know what, at the end of the sprint, at the end of these 2 or 4 weeks, I'll give you a feature called phone call, or I'll improve a feature called camera, or I'll give you one more feature, and etc. So each and every sprint has its own target. We call it as a sprint target. End of the sprint, this is what you have to develop and this is what you have to deliver. So now the development teams have a time bound mechanism wherein in the next 2 to 4 weeks they have to deliver one particular feature. They have to get that feature tested, and also as and when my tester is testing out and the feature is ready, I will use my operations team to release that particular feature or to give that particular feature to the end client. So at the end of each and every sprint, we are promising a client a particular feature. So if you look at let's say, if you say one sprint is 4 weeks, in 2 sprints I'll be able to complete a major feature out here. This is what I'm now talking about. But one issue still remains unaddressed. Even here the developer is using Linux operating system, tester is using Windows, operations is still using Mac. You are still bound to get issues. That is where I am bringing in a DevOps practice, wherein I am telling that if you are a developer, write your code in your system, not a problem, but store your code somewhere. Go ahead, store your code somewhere. Don't store it in your system. Storage of the code. In a traditional mechanism, you store your code into your system. I'm telling, in a DevOps practice, don't store your code in a system. Store it somewhere central. so that me, you, everyone can see what is happening. Me, you, everyone can see how it is, let's say, happening and track it out. And that is where repositories come into picture. Like Git, GitHub, Azure repositories, TFVC, Bitbucket, a lot of things out here that are available out there in the market. So I'll say repos. We'll put a diagram also for that one. Repositories. Great. Planning. That's also a major activity. Each and every sprint begins with a plan. Plan it using something known as boards, BOARDS boards. Or if you are coming from an open source, something known as Jira, planning and seeing your day-to-day activity and all these things out. Thirdly, the developer is writing the code. Writing is different, developing is different. Developing means he's writing the code and clicking on that build option to go ahead and build the code and change it to DLLs, zeros and ones. Here I'm telling development should not happen on the local system, because if it is happening on the local system, it's taking the flavor of your operating system. I don't want to do that. In a traditional mechanism, development happens on a system. If that happens, configuration issue starts. Now I'm telling develop it on the cloud. Don't develop it on your local system, develop it on the cloud by using something known as build pipelines. Pipelines. If you are using, let's say, build pipeline using Azure DevOps, or you have equivalent tools like Jenkins. You have something called Never Code, Buddy Build. A lot of tools that will help you do the code development. When I say code development, I'm converting my code from a high level language to a low level language out here. I don't want to do it on my system, because this code that I do it on my system will have an influence of my operating system. Testing, I'm now asking my testers to write their test cases, but not to develop their test cases and execute their test cases on their local system. Do not execute your test cases from your local system. Rather, execute it on the pipelines as such, using your Azure DevOps pipelines or using something like Jenkins pipelines, etc. Operations, I'm asking them also to use the pipelines to test it and also to release it using the pipelines. Onto a cloud like Azure, AWS, GCP, on-premise servers, wherever you want destination is, go ahead and release it. So if you see this one, you have repositories, you have boards, you have build pipelines, you have testing pipelines, you have release pipelines, you have a lot of things. All these things together will constitute a tool or will constitute a technology called DevOps. And you need a person who's called a DevOps engineer to firstly understand how do you store your code. There are concepts here telling Git branches, strategies, let's say multiple things like protection and all that stuff, policies and everything. You need a person to understand how to create pipelines. You need a person to understand how do you manage pipelines. You also need a person after you release the code onto the pipeline, meaning using the pipeline onto Azure cloud, how to monitor that code using application insights and various tools, etc. So you need a person who has a knowledge of the cloud and who also have a knowledge of this particular tool called Azure DevOps. And that's where we as a team come into picture, who's a DevOps engineering team. Again, DevOps today is also being called as SRE, Site Reliability Engineering, or DevOps Engineering. Anything is okay. Any terminology is okay. SRE, DevOps, and all that stuff. Not a problem. So if you look at the DevOps practice, if I say just click on Azure DevOps, and if I look at the diagram of Azure DevOps, which we did in the very first class, looks something like this. So now it's telling that, okay, let me open a full-fledged diagram out here. Let's see if I do have one. I don't know where I save it, but let's see. Let me open a full-fledged diagram of the same thing and see. Okay, so this was the slide that I've used in the introduction. And if you all remember the introduction class about 40 days ago, we did in the introduction, we said what is Azure DevOps and all that stuff. And this is a diagram that we were using. Now this makes sense, does it? Sorry, let me come here. Let's see. You are storing, firstly, you are planning using something called what? Boards. You need a DevOps engineer to give you something known as a board. You're storing the code in what? Repository, Git, GitHub, whatever it is, or Azure repos, whatever it is. You need a DevOps engineer to understand this out. Then you have what? Pipelines to build your code, test your code, release your code. You need a DevOps engineer to create this out. Artifacts are nothing but the byproduct of a pipeline. In your local machine, you're calling it as zeros and ones or DLLs. The same thing you call as artifacts in Azure. You need a person to understand artifacts. You need a person to monitor this out also. And then after monitoring, you need to also give a feedback planning. So all these now is happening in a cyclic procedure by implementing something called as a DevOps practice. And you need a person or you need an engineer to understand the practices of DevOps, and that's where we come into picture to go ahead and give you something called as a DevOps practice out here. And over the next over the next, let's say, couple of weeks, we are going to understand each and every component of this particular tool called Azure DevOps out here. And again, just like Azure Cloud, if you want to go to Azure Cloud, what will you do? What will you do if you want to go to Azure Cloud? Portal.azure.com. If you want to start using Azure DevOps, you will say, instead of portal.azure.com, you will say dev.azure.com out here. This is the page where you, let's say, I'll say no, this is the page where you will start with something called as Azure DevOps out here. Yes, I'll take a quick pause here. Any questions still here on what do you mean by DevOps? How does it improvise the quality of your code? And what do we do as a DevOps engineer out here as such? Is anyone any questions still here? DevOps kind of works for multiple projects, meaning it just depends upon how big or how small a project is. If a project is too small, you are able to support it. You'll be able to supporting, let's say, one project, two projects, multiple things out here. The same practice can be applied to multiple projects. So if you know how to apply it for one project, the same can be replicated into multiple projects as such. So sure. Mhm. Okay, that's fine. Even in the same project, you can have configuration issues. Even in the same project, you'll have multiple teams, development QAs and everything. QA needs a different laptop out there. Your operations needs a different laptop out there, and etc. Even if in the same project, you can have multiple configuration issues. That's where DevOps can come into the same project as well. No, I don't want them to use the same kind of OS because the softwares that run on a Linux operating system may not run on a Windows operating system, which is needed by a QA. The team skill set is different. As a QA, I'm not expected to even know the basics of Linux. I don't even know the basics of Linux. How do you expect me to, let's say, work on a Linux operating system? Is what your QA will ask you. That's the reason you can have, yes, you should have, let's say, multiple configurations without having to affect your software development quality. That's where you are getting in DevOps and doing all the software development on the cloud, not on the laptops. If you still had repository concept of repositories like TFVC and all these things out, but very primitive in nature, like very primitive in nature, very limited functionality out here. Still, I mean, even in if you go back in the earlier days, then yes, shared over mails or something like that. Like it's a very old days out there. But right now, no one is doing that. Everyone is putting their code on a repository and then sharing it out. They have a repository, GitHub Enterprise. They have a lot of things out there. Yes, any more questions here? Definitely, you have to maintain the repository. You do not, I mean, not even maintaining, you'll have to start creating repositories also. Repositories, there's something called branches inside repositories. You'll have to create repositories, branches inside the repositories, maintain policies, maintain the branches, and all these things out. You'll have to create build pipelines, maintain build pipelines. You also have to maintain Azure cloud. So the hmm? Executed, yes. You will have to, let's say, build a pipeline to execute that build pipe, or to execute that, let's say, test plan, or to, let's say, develop that particular code and all these things. And now you see why why this team is getting very, very versatile, because a lot of, let's say, companies are now into the DevOps practice. Even small companies to develop small software, they want a proper, let's say, configuration management. They want a proper life cycle. They want a proper time and all these things. So the DevOps team is, I would say, is now becoming a little versatile out here to, let's say, implement and all that stuff. Yes, any more questions here? Anyone? Any more questions here?
Hi, Kiran.
Just a second, I'll come back to you. Yes, go ahead, please. Someone online had a question.
Yeah, actually, this DevOps configurations and subnets, virtual machine
Mm,
configurations, and all single time
mm.
activity in the project, right?
Okay. Okay.
Hello.
Sorry. Just come back. I'm just coming back to your question. Sorry, I was reading something else. Is
Okay.
it a single configuration in the project? Not
Hello,
really.
single time
No,
configurations in the project, right?
not really. It can develop over a period of time. As the development goes, the demand of the pipeline can also be robust. The demand of the pipeline can also
Okay.
increase. So yes, this can be a continuous process of improvement, continuous process of, let's say, adding multiple things into your pipelines, multiple, let's say, testing tools into your pipelines, and a couple of things out there.
Okay, then coming to admin part, that network configurations, virtual machine configurations, that
Mm.
might be single time activity, right?
Again, even that doesn't have to be a single time activity. Depending upon,
Okay.
let's say, you have released your code onto an app service. That app service is not sufficient. Now your team is telling that, you know what, I need one more app service. So you can have a ARM template in place, configure your app services, run the ARM templates from a DevOps practice. So it can be a continuous demand. Again, even that
Okay.
cannot be a single, or even that sometimes cannot be, let's say, a one time, let's say, setup. Even that can be a continuous setup out here.
Okay.
Again, it just completely depends upon what kind of a project that you're actually working for, how you're working for that project, and all these things are.
Got it. If it is a stable project, it might be that is different.
Even if it's a stable project,
Okay.
I am initially starting with Android version 1. I have created a web application for Android version 1. I'm now getting in Android version 2. Now my team is telling, you know what, I need both Android version 1 and version 2. I need to create one more web application. So if you see,
Okay.
your life cycle is going around from version 1, version 2, version 3, and so on and so forth. And for each and every version, you are going ahead and creating multiple things out here. You create, let's say, multiple pipelines for some time, let's say, for multiple versions as such. So it just depends upon, again, even if it's a simple project, if it has a complex lifecycle architecture, then your development, your operations, your testing, and your DevOps should also be complex. So completely depends upon your product, the life cycle of the product as well.
Okay.
Yes, I'll
Thank you.
just take a question offline. Yes, good. Please. I'll just come back to you just a second. Yes. Mhm. Is there a time to extend? You can extend the time, but the no client will give you time. But the thing here is that in this process, we want to avoid that asking of the extra time, because you're asking time. Client is also giving you some money, and even they are waiting for the software, right? So in the process of, let's say, DevOps, the process of DevOps, or the end goal of DevOps, is to deliver the software in time and to deliver an efficient software, not only in time but also an efficient software. Yes, go ahead, please. Mhm. Not really. You can have your test cases built inside the development pipeline as such. You can execute test cases from the pipeline. We'll also see that. Mhm. Yes, because each and every phase of your software development needs one kind of an approach. Again, even if you look at any kind of a product, right? Initially, they'll test it out to see whether the stability is there. Later, they'll test it out to see whether, let's say, it's running fine. Later, they'll test it out to see whether what kind of a load it is handling. So, depending upon where your software is, the test cases also need to change. You cannot put all the test cases at once; it will fail. There's no point in moving forward. So, testing should also be incremental, like the development is, because for the initial first sprint I'm just doing one particular piece of component. Testing should also only test that. Second iteration, my developer is adding one more piece of component. Now tester should or test it, first component and second component, and see how they both, let's say, work together. It's a holistic way of testing out there. That's the reason when developers develop, right, they only test that piece of software that they develop. When the tester tests it, they test it holistically. So it just depends upon what kind of a team you are in and what they really need out there as the end product. Yes, it is mandatory. Sprint planning will become mandatory because anything starts the plan. Even when you want to take this course, you had a plan telling that, okay, fine, this is what I need. So anything starts with a plan. So before you start a sprint, you need to have a very clear goal telling what are the items you want to complete in the sprint. What are the testing you want to do in the sprint? What do you want to do in the sprint? So sprint planning becomes compulsory, for which Azure boards come into picture. Boards as a, let's say, piece of tool comes into picture to help you out. Again, Agile and DevOps, they kind of profess the same thing out here. Agile just tells you that, okay, fine, work together in teams. Do not, let's say, work individually and all that stuff. DevOps tells, okay, fine, on top of Agile, I'll add one more thing, telling do all these things but on the cloud. So DevOps related. So DevOps and Agile are very closely bound together. Again, even when you say DevOps, DevOps is a practice. Agile is a methodology of software development. So you're just implementing a DevOps practice on an Agile methodology. Yes, any more questions here? Let's see. Okay, I was just taking a question offline. Let's see this. Okay, let's see. Venkat is asking, as you said in demo, after 35 classes like Azure Administrator, mock interview will be provided. Okay, mock interviews going on in institute right now. No, they aren't mock interviews that are going around, but we can plan it on the weekends. We can take Saturdays as mock interviews, and depending upon the number of students, that they want. Again, before you give me the mock interview, you also have to tell who should I interview out. If I say who should I interview out, you also need to give me your resume, telling this is my resume, this is my profile, and depending upon your profile, I'll interview out, telling how the questions will come in and all that stuff. So these are the things that we need to do. So it's a two-way bridge. You will have to tell me who I interview and all these things are, and I will also go ahead and, let's say, conduct those interviews, and we can do the mock interviews on a Saturday and a Sunday as such. Like we can take half an hour, we can understand how the interview goes around, and we can then analyze what the interview, let's say, what can be the improvement areas and all these things are. Here, DevOps engineers plays a key role. So teams like development, testing teams will be user repository sharing the code, right? Again, all the teams play a crucial role. I wouldn't say just DevOps, because just DevOps cannot really do anything. And DevOps is just helping out teams like development, testing, and all these things out. So yes, you create the services like repository, pipelines, and etc., which can be later used by these teams like development and testing and etc. Yes. Any more questions here?
Kiran, any sample resumes?
I'm sorry. Can you come again, please?
Any sample resumes? How the format for that
Yes.
works and uploaded?
What you can do is that I don't have the updated sample resume with me. You can check with the front office, the same number that you get the, let's say, links, daily links from. Just post it in
Okay.
the group asking for sample resumes, and they'll be able to send you the sample resumes. Once you get a sample resume, work on those resumes, send it across to me. I'll review and I'll, let's say, tell you what are the areas that you need to, let's say, address. And then we can, let's say, a couple of emails up and down, and then you can, let's say, go ahead and roll out your resume as such.
Okay. Thank you.
And you can start rolling out your resumes, guys. Like admin part is almost done. So you can start rolling out your resumes out there. DevOps will take around 15-20 classes, as we earlier said, the initial DevOps, and after that you have open source like Terraform and all these things out. Those together, again, I'm talking about a month from today, like give or take 30 classes from today is what I need to complete the curriculum, is what I would need out here. So you can start rolling out your resumes. Your interview schedule process will take some time. By the end of this course, the goal is that you should have a job. That's how we basically time things up. Okay. Is any more questions here? Okay, from tomorrow we'll then start with Git repositories. We'll see, understand what is DevOps really, how do you configure Azure DevOps and all that stuff. And from there we'll get started. Okay. Thanks guys and have a good day. Thank you.